Hey, hi all. Welcome back to my channel. In today's video, we'll talk about the evals. Right. When I say evals, right, it's evaluating the generative AI system. Why do we require it? Because we want to deploy our agent on production graded AI agents. We want our agent to work as per our expectation. We don't want to be agent will hallucinate. As we all know, AI agents are always difficult to determine, I say, right? They might be generate some result which is not acceptable, which is not specifically good for the models, right? And something they will generate a result out of the context. So by seeing the nature of the AI system, so we have to be very much, very much care to be taken before deploying that. Just like we use unit test whenever we do any kind of deployment of our code like Python or something, right? So we do a unit test. Similarly, so when we have to deploy the AI agents, we have to be consider these factors. Production grade AI agents can be deployed only using the evals. We have to use these various evaluation metrics to understand the behavior of the AI agent when deployed on the production. Let us take a case. So there's a concept called confusion matrix. I have documentation in front of you guys. So what does confusion matrix is that? So let me provide some details on the confusion matrix. So let us take a case. So a guy goes to a doctor and doctor predicted he has a disease. Similarly, he used the AI system. Sorry, guys. Similarly, he used the AI system and the AI system also predicted the particular disease. That means doctor's prediction and the AI system prediction is positive. It comes the true positive. But there might be a chance doctor predicted a disease, but AI model will not predict a disease. That comes under false positive, right? Similarly, there might be chance model predicted the disease as a negative, but it was actually positive. That's the false negative. And true negative. Model predicted negative, but it was a really was a negative, right? So that means we have to consider these factor confusion metrics, right? Let me show you here over there, right? For example, so you can see true positive, true negative, false positive, false negative. Doctor predicted is model predicted is. Model prediction, doctor prediction is same. Here, model predicted negative, doctor predicted positive. True negative. Model predicted negative and it is actually negative. False negative. Doctor predicted negative but model predicted positive. So these are the important parameters that specifically considered while deploying the agents on the day. But why do we need confusion matrix? Because evaluation parameters depend upon those values, right? Depend upon those values. So important factor to be considered is the precision, right? So when we have the true positive and false positive value, we get the precision score, right? For example, true positive is 32 and false positive is 8. So we will get the score of 80%. That means our model, one of the parameter which is known as precision is quoting that the model is behaving right. But this is not only factor we have to consider. We have to take another factor, recall. asked for everything was actually positive, but how much did the model catch? This makes the coverage how good the model is and not missing the real case. Here again the formula recall equal to true positive divided by true positive plus false negative, right? So we get the 80% score. I will show you a demo also so that you can able to understand how this will work. Yesterday, I did create some AI agents using the ADK graph too. So I will take those example and let you know is that the particular agent is good to go for the production or not, right? Third score is considered as the F1 score. This is rarely very important. F1 score is the harmonic mean precision and recall. It's the mean of the precision and recall. Whatever the value you will get for the precision and recall, it gives you the mean, harmonic mean. Harmonic mean is the formula is given. 2 into precision to recall divided by precision per recall. Right? So this will give you the harmonic mean, right? So you have to be considered this. So among the recall and the precision, F1 score is very important, right? Sport is simply a number of the true upon the actual instance of the given the class in the evaluation set. How many real examples the label had, regardless of what model predicted. It is not a score, it is a count, and it is essential to context the reading of the other three. So when we put all those things, so we will get some score like this, right? Billing, for example, if you're talking about a billing agent, shipping agent, journal, so we will get some score, accuracy, right? So some score, okay. So we have some scores regarding the macro average and weighted average, so we will got some score. So based on that score, we will find so whether we want to go for this model for deployment or not. Again, the question is which score is matter the most? As I told earlier, that F1 score is considered, but still again the use case. For example, if you go to banking system, right? If your model is predicting negative, your model is predicting positive, but it's not actually positive. That is, it's a big. Then there might be chances of fraud because the account says the personal account has exist, but model says it does not exist. So we have to consider all those use cases, right? So that's why when we do normally in our CI/CD pipeline before merging it with the main branch, we always try to go for the unit testing, right? Similar way we have to go. Let's go to one of the examples on this, which will let you know on this, right? So let me put over there. You can see over there, right? So here you can see I have one example. I have already written this code, right? Already. I have a file where I have written the whole logic of our agents, which we created yesterday, right? And showed that, right? So in that case, so I'm using this rotor.py and just trying to evaluate based on that whether this model, this agent which I have created yesterday is good to go or not, right? It's good to go or not, right? Important thing, right? Agree? So, for importing some libraries from pandas, I use scikit-learn metrics, right? And import accuracy score. All the specific evals I have used import from there, from scikit-learn, right? So from routing workflow definition, import. So I have import this one. Then I have used the routing workflow, import router node and the get predicted route. So in yesterday lecture, specifically video, I've shown you the one diagram in which our start node, right, is hitting our router node. From the router node, it is based on the decision, right? So it is sending the request to billing agent, then is shipping agent or the default agent, right? So we have created one data set to evaluate, right? Just as example. For example, if somebody asks, I need to know my recent charge. So it is labeled as a billing. Can I get a refund of my order? It is labeled as billing. Where is my package right now? It is shipping. My bill seems to be incorrect. It is billing. So every user query is labeled, whether it will go to billing agent, whether it will go to shipping agent, whether it will go to this, right? So we have already given the instruction. If anything goes with the charge or something go to billing, if something go like this, that will go to the shipping. Somebody asking about the tracking of the order, it will go to the shipping, right? So, but we have to create some of the sample data set, and based on that, we will try to evaluate how our models are good and accurate, right? It's a simple Python, right? For item and evaluation data, whatever data evaluation data is there. So we just route the output. So whatever user message will come, right? It will based on the user message. So it will route out, right? So prediction, it will append the it will append the whatever the predicted route over there, right? And based on label, so we will get the from this, I have created one data frame, right? Whatever result I have created some data frame, right? And then I will measure it, right? Let's run this, right? So it is running. You can see I got out. Here, I need to know about my recent charge, billing, predicted billing. That's a true positive. Billing, actual billing, but predicted also billing, right? Let's create some of the false one, right? Here, my order is delayed. Who can help? Right? True level is shipping, but model predicts to the default one, right? I receive a damaged product. What should I do? Right? It go to default. It's go to default, right? So if I found more examples, okay, this one. My subscription was renewed unexpectedly. It must go to billing. It go to default agent. So based on that, so accuracy of overall is 0.90, right? And we got the score of this one. Session score we got the 1. Recall we got the 0.83. F1 0.91 and sport we got 6. Right. Right. And for different agent, if I talk about the default uh, shipping agent, we got the precision score equal to 1. Recall equal to 0.83. F1 score equal to 0.91. Okay, fine. Right. Similarly, so micro average, weighted average, we also got. So on an average, the F1 score of the three agent is 0.91. So with this, we are good to go with the production. So in this way, we use Evals to determine whether our AI agent is good to go with the production or not. I hope you like the video, right? And specifically kindly like and subscribe, right? For more such videos, I will do cover the security part also, guardrails also, and in a future video I will do cover the specific over the observability also, right? These are the most important things when we go for the AI agents to be created. Thank you guys, thank you for your time. Thank you. Thanks for watching.